disclaimer, I think if you come closer, you'll achieve more listening to this talk because you'll see things on the slides. But if you don't care about the talk and you want to go to arcade, feel free to stay at the back. No shame, that too. I'll just wait for half a minute more until you see it. Okay, cool. Okay, let's start. My name is Migas. I come from Krakow, Poland. I live there on a daily basis as well. I work as a lead UI developer at Field Intelligence, where we take care of supply chain for pharmaceuticals on emerging markets. Currently, we operate in Nigeria and Kenya. I also hold title of Google Developer Expert in the Web Technologies area. And I have the specialization in web performance because this is sort of my passion after hours. I don't work as a dev role, so web performance has been my passion for many, many years. I've been speaking and excited about web performance for over 7 years, I believe. If you're interested, you can scan the QR code, find me on Twitter. Otherwise, you need to type in Shinshadishas if you want to get my handle. I think it's impossible even for Polish people, so yeah. The title of today's talk is Demystifying Web Performance Tooling and Metrics. And during the talk, we'll chat about, first, what is web performance to get everyone on the same page. Then we'll differentiate between load, runtime, and perceived performance. We'll talk about web performance metrics in detail. Then we'll go to tooling, including a small demo. We'll see how much time we have for that and how easy it is to type, because this is like quite low. And then we'll go to the short summary. So, what is web performance? The definition on Wikipedia says, web performance refers to the speed in which web pages are downloaded and displayed on the user's web browser. But as you will find out in a second, this is only one subtype of web performance definition. So let's talk about that. Let's dive into web performance types. First, we have load web performance, and this is to what this Wikipedia's definition was referring to, because this is about how fast things are loading, and all the things are related to the time before the page is loaded, basically. And it's influenced by the network connection, the device capabilities, general shape of your code. And to improve it, you want to look into basics like reducing the size of the bundle, setting up the correct CDN, content delivery network, to make sure that the latency is not an issue for your user, minify the content, fix cache. Basically, all the setup things are important for the load performance, as well as some other things about which we're going to talk about later. Then the second type of web performance is runtime web performance, and this is mostly what happens after the page is loaded when the user is trying to, in some way, interact with the page. So like if the response from the page is delayed, or if the animation is feeling sluggish, like here, this is all the part of the runtime performance. And why is runtime performance problem even occurring? Why is junk occurring? Because what we're seeing on the screen is junk. When we see this, a bit of jittering and browser not being able to service a smooth animation or like smooth experience in general, this is because the browser is overloaded with work and it's dropping frames. So if any one of you was before at the talk about the main thread and offloading the main thread, you already know that what browser is trying to do is trying to serve the frames in a correct frame rate. The frame rate in which your screen, your device is refreshing. So for most devices it would be 60 times per second, for some devices 120 times per second. And basically, browser needs to make all in its power to create that many frames every second so that you would have a smooth performance. So it's not that much time to give user like 60 frames 1 second, right? And if we put too much work, like especially too much JavaScript, like too big functions, too big calculations, then the browser doesn't have time to do this, and then it's dropping frames, and what we see is junk. So this is influenced by overloading the browser with work, basically. And to improve it, you want to reduce the amount of work for the browser. You want to consider code splitting, because this will help with having smaller functions, smaller files to parse. And you want to optimize animations. For example, animating some properties will create junk because they are not being composited, they are not happening on the GPU, and they are slower in general. And the last type of web performance is perceived web performance, which is overall feeling about the web performance and the user experience and overall feeling that we get from the website. It's throughout the whole experience of looking at the website, and unfortunately it's very hard to optimize because it's subjective. For some users, they might feel like the website is not performing well, even though there's no real web performance issue. Maybe your animation is just like slower, and it's your design, but for them it might feel like the web performance issue is occurring. So knowing all that, let's dive into web performance metrics, which I think is the most intimidating part for each of the users that that's trying to dive into web performance, because there are so many metrics. All of them sound similar. Everyone's using abbreviations. They all have the same letters in them. By the way, I don't know why, but this is yellow on my screen, and here I can see it's white. So this is just really interesting. I wonder if like all the slides are going to be also altered. So all these metrics are there, and you should know which ones of them you should care about, which ones of them you should be optimizing. But before we jump into that, we need to talk about the difference between lab and field data, because this is really important, and this is something that a lot of people starting their journey with web performance get wrong. So these are basically two types of data that you can have. Lab data is a result of the test in some specified environment. For example, if you're running the Lighthouse test, or if you're using page speed, part of this result will be the lab data, which is fake. It's like in some specific environment, specific speed, specific laptop combo, and it's not a representative of what is really happening to users, but can give you some answers, can be helpful to you to, for example, start optimizing. While field data, this is the data we get from real users based on like real activity that we're having. And this is something that will tell us what is really happening to our users. Going back to metrics. There are two pools of metrics that are like known. First is core web vitals, and another is other web vitals. We'll talk about the difference in between them. So core web vitals term is coined by Google. Actually, other web vitals as well, but like I don't think it's like really like other web vitals is a term that is specific. So core web vitals. They are important because they affect the SEO. So basically, if your core web vitals are worse, then your website is landing lower on the results page in Google. And they reflect the real-world experience, so they're based on the field data, so whatever your users are really experiencing. And for core web vitals, there's 4 metrics. First is largest contentful paint, LCP. Don't worry, we'll talk about them in detail in a second. Then we have cumulative layout shift, CLS. First input delay, FID, which soon will be out. It was just announced on Google I/O that March 2024, first input delay will be replaced by interaction to next page, INP, which was experimental by now. Now it's proposed to be a real metric. So FID will be out, INP will be in. So largest contentful paint. This is about the render time of the largest image or text block visible within the viewport. So whatever your user is seeing when they reload the page, the biggest either text or image will be the LCP. So this metric is meant to measure loading of the page. Element tagged as LCP can change over time. This is important because for example, first you might see some small image, it's tagged as LCP first, but then something bigger loads and it's overtaking as LCP. You see it in a moment on a video. So this element can change over time as the loading is progressing. It also can differ depending on the viewport size. That's why you need to test both on small sizes, small screens, and also on the biggest screens. And it represents how quickly the main content of a web page is loaded. This is what this metric is about telling us how fast things are loading, basically. So you can see in this example that on the right side, you see that LCP was 65 milliseconds, 65, now it's 4.30 something. It's because first it was the startups text and then the invisible ad that's shown there overtaken as an LCP. What you can do to optimize? First, never add lazy loading on items above default, or on the items that are initially visible to the user. Some people will add lazy loading on all items as they go. Just don't do it for the items that potentially can be an LCP candidate. You want to make the resource discoverable. So if it's a picture, then the best is to just use image tag. If it's not possible to use image tag, you want to optimize its priority using preload hint or fetch priority high hint. So basically, you want to make sure that this image, if it's, for example, a background image, also gets downloaded as fast as possible to be shown to the user. It's not only discovered once the CSS is fully parsed. And basically, you want to optimize the load performance for the whole page and all the metrics, because the faster, like in general, it loads, the faster, for example, time to first byte as well, the faster LCP will show up. Then we have CLS, Cumulative Layout Shift, and it quantifies how often users experience sudden shifts in page content. So basically, if something pops up and if elements are moving around, this is what the CLS metric is about. It measures the interactivity, and it's only calculated for items that were visible and change position. So if a new element pops up, for it the CLS is not calculated unless it pushes away some other element that was already in the view. And it's hard to explain how it's calculated. I mean, I tried to read through this, and it's just like, basically what you need to understand from this is like, you want to move the least possible like items around on the page, because there's like some big calculations going on. You just want to like give like the least spontaneous movements between elements as you can. And as I said, this is the cumulative layout shift, so it's measured throughout the whole experience of a user with the page. You can see I'm just scrolling up and down in here, and it's like going up. I hope you see it at the back. But like basically, if users of this page are just scrolling up and down, then the metric for this new site is worsening. That's what I'm saying, basically. They might want to fix this. So the optimization tips. Make sure all items that can appear later on the page have defined size, so width and height, either in CSS or in the mockup, or they have defined aspect ratio. So this is about images, ads, everything that like pops up later. You want to save the space for that, at least like min height for this element. You want to avoid inserting content without user input, because this counts as like spontaneous shifts. You want to avoid animations that change layout again. You don't want any like animations of top margins, height of elements. What you can safely animate or transition is transforms, opacity, things like that that don't change the layout of the page. And you want to avoid font shifts as well. You don't want the flash of unstyled or invisible text if possible, or you want to minimize it as much as possible. Then we have first input delay. As I said, this metric is going to be replaced soon. It says how long it takes for the browser to respond to the first interaction, so basically first tap, click, key press of the user. I think interaction to next paint is a good replacement because it's about like all the interactions, so it's a bit more useful metric because I think first interaction doesn't like necessarily give you like the great information about the overall user experience, and interaction to next paint is very similar, but it says like how long it will take the page to respond to users' interaction with any visual feedback in general, so it's a singular value. It's measured, as I said, when user interacts with the page, click, tap, key press. It's about overall responsiveness in a single value. You see it in the video in a moment. It can be tested using Web Vitals extension. I'll share the slides later, by the way, on Twitter and in the Slack if you want to follow all the links that are there. And let's take a look at what was happening here. So you can see at the bottom in the red frame, we can see that it's waiting for the input from interaction to next paint. I don't know why, but all the websites for the like holiday deals in Poland are over time are getting worse. Like when you load more items, it's like always getting worse performance. And you can see it here that like every time it loads, it's just like slower. It's like interaction to next paint is progressively getting worse. So this metric, I think, is like really useful to help you find out any problems with overall performance that is happening over time. So what you might want to do to optimize INP. You want to do as little of JavaScript work as needed after users' input, because we want to show them any visual feedback after they interact with the page. Try to split long JavaScript tasks. If we have like long tasks, they block browser from being able to respond to the user. You want to leverage web workers, so if you have any heavy calculations, you want to take them out from the main thread that's responsible for giving visual feedback, building DOM, and you might want to shift it to the web worker so it happens in parallel. And keep the DOM small, because the bigger the DOM, the more there's for the browser to keep track of when it needs to append the change. I highly recommend seeing this talk by Jeremy Wagner about the optimizing INP. He gave this talk last year in Korea at the JSConf. I really, really enjoyed it. And Jeremy is also working on the documentation for INP and for a lot of other things around web performance. And I think he's a really great person to go to when it comes to learning some optimization techniques. So these were the core web vitals. So the ones that influence the SEO are counted by Google. But there are other web vitals, and they can be used to fix issues with core web vitals, and I think this is the very useful thing about them. They give you a wider view of the overall experience of the user, and are helpful to diagnose specific issues when it comes to web performance. First is time to first byte, which is personally my favorite metric. So I'm going to speak about it in detail. About other ones I will not, but I'll mention them. First contentful paint, FCP. It's similar to LCP in the name, largest contentful paint, but it's about how long it takes to see anything on a page, basically. Time to interactive is TTI. It's how long it will take the browser to respond to users' interactions, and then total blocking time, which is in between first contentful paint and time to interactive, basically. So like how long the browser was blocked. So let's talk quick about time to first byte, because it's really, really important metric. It's how long it takes to get the first bytes of data to the user. And to quote Harry Roberts, who's a web performance consultant, while good time to first byte doesn't necessarily mean you have a fast website, but time to first byte almost certainly guarantees a slow one. And this is very true because basically if you make a request to get a website on your device, and it takes long to get the first information in. Well, then everything is offset in time. It's quite, logical, and also a lot of time it will mean that other requests are also slower, because probably you have a higher latency. So what to do to optimize TTFB? Use CDN again, Content Delivery Network, to be closer to the users. Invest in hosting that is adequate to the needs of your website. I don't think you need to care if it's just your personal blog, but if you're running a news site, if you're running e-commerce, then you definitely need to invest in a great infrastructure. Consider using a service worker if your website is meant to be visited often, like more than once. Service worker can close the gap between your user and wherever your data is, basically. And now, after all these metrics, after all this dry stuff, let's go to tooling, which is a bit more dry stuff. So the tooling, I feel like we need to go through 3 phases when it comes to tooling and web performance testing. First is initial testing, so that we know like what we stand on, where our website is, like how bad it is, how great it is. Maybe we don't need to listen to the SOC, maybe we don't need to optimize the web performance, maybe we're like, great. So first place where you want to go to is page speed insights. All you need to do is go to the link, input the name of the page, and wait for the results. Page speed insights is great because possibly it will give you, apart from just the lab data, because like part of it from this metrics down, it's a lab data based on some like setup from Google. Sometimes it will also give you the field data if there's enough users who are using Chrome logged into Google using your website, which I think is fantastic because maybe you have some free stats of what's really your users are experiencing, as well as it has some diagnostics, opportunities. So like you can see maybe easily some really, really broken things on your website that you can improve quick. Similar to that is web page test, also inputting the URL, and it runs the test for you. There's a limited amount of free tests a month, unless you sign up then for free. Then I think you have a bit more. It also gives you like so much data, so much information about like what can be fixed, what is wrong, like if it's fine or not. I think it's like also a really fantastic tool, and it has loads of configuration options to make it as close to your users' environment as possible. Then, if you're using Webpack, then the things can get a bit hairy, because after all, what Webpack is doing is like taking the JavaScript, and a lot of time it will just bundle it all into then one huge JavaScript file, which can be a few megabytes, as it turned out in this case. This is really useful because the bigger the square, the bigger the resource. And I think it's like really useful to start debugging. For example, in this case, we found out that using React Icons library, as it was described on the documentation page, made sure that like every time you picked one icon from one set, it downloaded the whole set, which resulted in like 2 megabytes of icons gzipped being shipped to the users. So thankfully we found out. And then last but not least from this first benchmarking part is Web Vitals extension. Is from Google. It's very, very useful because you can see all the metrics, the core web metrics calculated. So you get it from the Chrome, whatever the store is, like with extension named. You just install this, and if you have it at the pinned, then you can see it on all the pages as you interact with them. Obviously, this is the lab data because this is using your device, your device's capabilities, your device's connection. But still, I think it can be helpful to spot some issues, especially that you can, after right-click on this, you can have the options. And you can turn on console logging and user times. And I think it's really useful because with that, you will know, for example, what the largest contentful paint item is. This is, you have like the sub parts of the LCP element, like what is taking the longest while this was rendered. I think it's like really useful insight, and it's being console logged. If the extension is pinned, it's been console logged to for every page you're visiting, basically. So that was initial testing. After initial testing, we need to go through optimizations once we know where we stand on. And there's quite a few tools for that. Most of them are in the Chrome DevTools again, because I think they have definitely the most robust DevTools for performance. First is the network tab, which looks very intimidating, but we'll do a short demo about this later. For the people in the back, you won't see anything, so you might come closer and like be judging later if you're interested. After all, you can also stay there and be judging as well, maybe a bit. So network tab available in Chrome DevTools. It's great for testing the load performance of this type of performance we're talking about. The most useful tool, like hands down, it's like it easily gives you so much information when it comes to the load performance, but the setup is the key. That's why we'll take a look at that in a moment. Then we have performance tab, which I think is the most intimidating tool for all people I chatted about this with. It's basically you try to see something there, and at first, if you don't know, if you didn't watch any tutorials, like it looks like nothing. It's just like some dashboard, very complex. So performance tab is available in Chrome DevTools. It's great for testing runtime performance, so the second type of performance we talked about. Useful but hard to read, and there's an alternative to use now. It's called Performance Insights, but I believe it's still experimental in Chrome, but my feeling is they want to replace the Performance tab with Performance Insights tab, but they still are working on this tool. Then we have the Lighthouse, which is similar to what PageSpeed Insights gives us, but we can use it on local pages locally in our browser, which I think is useful, even though it's still the lab data. I think it's great for checking opportunities, and it's easy to see the progress as you work on things, because you can run the performance Lighthouse reports every now and then after you try, for example, I don't know, loading fonts earlier or something like that. You can see if it's helping or not. Obviously, you then need to check the field data after some time, but it's helpful to see progress. Disclaimer, Lighthouse score, great Lighthouse score doesn't mean that the performance is great, because there's like a lot of tweets about like, yeah, I have like 100 in Lighthouse, my page is like so performant. This is not true, because this is like just specific set of metrics. Also, as I said, it's lab data. So if you have like fantastic device and fantastic internet, it can be 100, but for my colleague in Nigeria, it can be like 60, you know, you never know. Last but not least, the rendering tab. It could be found if you go to the Chrome DevTools, and there's this three dots menu on the right, and you click More Tools, and then there's Rendering tab. It's really useful for also runtime performance. You can see things here like paint flashing, layout shift regions, layer borders, also the Core Web Vitals overlay, but it's like a bit more shit than the one from the extension, I would say. Although it like runs smoother, but it's like less specific. But these tools are really useful for the runtime performance, because we didn't talk about it in detail, but this like paint flashing, layers, and all these things are the things that browser needs to do to give the user the frames, like to give user the smooth experience. The more is happening, basically, the slower the page can be, the more junk we might experience. So these tools are quite easy to use. You just turn them on and you interact with the page. The more you see, the worse it is, basically. So it's available in Chrome DevTools. As I said, great for testing the layout issues. paint flashing layer borders, web fighters overlay. And now it's a demo time, but we'll see because like it's so low in here, I might not be able to do anything. Okay, so first things first, we're going to be using Chrome DevTools. And if you want to go into testing web performance, basically what you need to do is either use the incognito mode, or you want to set up a new profile in your browser, because otherwise, first of all, you usually have extensions. They can influence the testing. Also, you can have different setup in the different profile, which can be helpful. Maybe you'll use some experimental tools, or basically, you might want to have different setup in the separate profile. So this is my performance tab. And for today's testing, I thought we're going to be looking into the website of NetGuru, which is the design studio in Poland. They recently had a redesign, and it's been quite, I think it was like really cool redesign, and I think that definitely there's a lot of things that we can see there. So let's head to the netguru.com. So first thing that is going to happen if you go to the network tab, you see a lot of things. Let's see. I think this is going to be visible even to the shy people at the back. Although it's very hard for me to now see anything here. So first thing that you see is like a lot of things basically. All right, let me just check the time so I know when I need to stop talking. Okay, so we have this this table here, and it shows you in the order all the resources that had to be downloaded to display this page. This page is in the background. I'm just not looking at this basically, but I'm looking into the tool first. So we can see that there's quite a few columns. If you do right-click on any of the columns, you see that you can add more of them or remove some of them. A very useful one is priority, which is not added by default. Also by default, everything is sorted by the waterfall. So this is how loading progressed. So much things are happening when you hover over things. So what else can we see here? At first of all, disabling cache is really useful when you're trying to test performance because, well, obviously you see the things, not the cached things. You can add throttling, network throttling. It's fake throttling. I mean, it can be useful, but not really because it's all fake, right? But if you're interested, you can see how it loads fast, or you can use the offline version if you're if you're working on the PWA. Then we can see at the bottom, we can see the amount of requests that were needed. We can also see the amount of data transferred. So this is what's gzipped, what was transferred gzipped. It's quite huge, isn't it? 8 megabytes. And then this is what was after unpacking this gzip. The finish time, how much it took for the DOM to load, and like general load. First thing we can see, we have 101 requests, 8 megabytes. We can see what will happen if we accept cookies. 146 requests just from accepting cookies. Okay, let's now scroll down the page. We can see that a lot of requests are happening. What it means, there's a lazy loading, and not all items were downloaded at first. By the way, like I know this page is like really heavy, but it's also very visual and very pretty. So I think it's at least justified in here. You know, it's not like one ugly thing, but we'll see in a moment. Oh god, this stuff was not what I wanted. So we know that there's lazy loading. Okay, other things we can see. You can see here filters, so you can input anything. It will just like filter the list of all the requests made. These filters here also are useful for that. For example, we can see, okay, there's like 1.1 megabyte was just fetch requests. JavaScript was also 1.1. CSS 0 means CSS and JS probably. Awesome tool. Images 1.1. I was honestly expecting more. I was expecting more. You can also always order by, for example, size if you click on this column. So we can see that some of these items have been around 400 kilobytes for images. I think it's like excessive. Definitely could be optimized further. Okay, let's go further. Media, 6.8 megabytes. Well, we see here some header background. If you click on any of these items here, it will give you some more information like request URL, just headers in general, sometimes preview, not in case of media, response, the timing. Timing is really useful. I'll tell you in a moment why. But let's see what is. That is waiting how much? 1.6 megabytes. 4-second video of a moving item that is used to wear here as a cover for some, I don't know, user story or something. So you can see that, well, is it worth it? I guess probably not. So this type of things can be found. So you can see that media was 8.4 megabytes out of 11.9. I think that's like really a lot and definitely could be optimized. So this is where all this bundle size is coming from. Another useful thing, here on the right, if you click this cog, you have some more information. Especially useful is large request rows. Can't see what's going on here. I think you maybe too. So large request rows will help you out because it will show you the size. Now you can see that there are two values, and one of them, what you see, is gzipped size, and one is the real size and pack size. So if they're equal, it means that something has been not been minimized gzipped. So definitely there's a lot of opportunities here. Another thing you can see is the time. The one at the bottom is the latency, so how the network latency basically offset the loading, and the rest is like the total loading time. Okay, so I said that this information. Okay, let's sort by waterfall. This information here, it's going to be really useful in the timing, and it's because waiting for server response on the first call, it will always be the time to first byte. So we can easily see how long it took for the first bytes of information to get to the user, which I think is like really useful to know, and see if you need to optimize, for example, your CDN or something. And last but not least, third-party requests. So you can filter out only see your third-party requests. So we can see it's 111 out of 155. Really useful thing that you can do. Let's find something. Okay, we can see some cookie law org, right? If you do the right-click on this item, I don't know why it's so much smaller, this popover, but you can add, there's the option to block request domain, so you want to click that. It will open this panel for network request blocking and add this domain right away into there. And now if you refresh the page, you see how many requests are made when this item is blocked. Obviously, it's like, I know it's only 3.2 megabytes transferred now, but definitely a lot of things have been cached or stored in service worker. But in general, it will help you out with like knowing how much of the liability a certain domain can be. So it can help you out with testing. And then we talked about the performance tab. There are two ways you can use performance tab. First is like you can just record some interaction, and the second one is you can reload the whole page and measure performance, which we'll do now. So like the page got reloaded in the background, and always I think like people are the most intimidated by that. So what you want to look out for in this tab? Okay, you know what? I think we need to clean the side data. What are we doing here? Oh, okay, we have request blocking. Let's tune out the request blocking so that we have a good overview of what's going on. Clean this test and run it again. So what you want to look for is clues in this panel. First of all, yeah, we couldn't see it without this cookie banner or whatever that was. You want to see places where there is some red in the CPU on the top. So wherever you have like the higher bars, the more activity, it means the browser was struggling more with the runtime performance. Obviously, during like loading the page, you don't care about it that much. But if you have some sluggish interaction or animation, then you might want to record this and see it in a panel. So you can scroll into this part and it will tell you when you have, for example, here we can see there's a layout shift. Usually it will tell you if you have some long frames. Tip, if you hold shift, then you can scroll like a normal person in this tab, otherwise it just scrolls in and out. And I think it's like a big hurdle for a lot of people. We can see screenshots here as well. It's not an obligation, but it's useful. So basically what you want to look for in there is like the big tasks and see what was like going on and try to split them into small ones. Here hidden at the bottom, maybe you can see it like right from the start. For you, there's like another panel. What is useful in here from the bottom up, if you group by domain, there's no grouping by default, it will tell you how much scripting time it took. So like there are big images that can take long to download, and there's big JavaScript that can take a bit shorter time to download, but might have like a bigger impact on how the page is behaving, because for the browser, like obviously like taking care of the script and understanding the script takes longer than just passing an image. So this can give you quite a good example how this cookie law, whatever thing is potentially making the performance worse on this page. As I said, there's also this performance insights page. There's an alternative that is being worked on now for the performance tab, because performance tab is so hard to read. I mean, you saw that there's so much going on in there. I wouldn't say that this is particularly easier to understand, but it's experimental, it's being worked on, right? So from the things that you can see in here, well, you can scroll in here, you'll see like how everything is progressing. You can find out what was your first contentful pane, DOM content loaded, LCP, TTI. So you can find out about all these metrics, like how they look on your page. By default, it's grouped by domain here, which is helpful because you can see how many domains your website is using, and we can see that some of the threads are like some domains are being reused, like netguru.com. So it's good to reuse the domains basically for the performance. You can see the renderer also, like you can see if there's like any long tasks or not, if the service worker is used, or if someone's using the web worker, which is great. It would be good to have some more activity in here. But what I find particularly useful is that from this navigation event, we can see some things in between the regular parts of the loading on the page. So for example, we can see, okay, there was some render blocking requests, and it will give you some details. It will tell you how to fix it. It will tell you which script was the part of this problem. And I find it's really useful for, especially like if you don't know how to read things, that this is going to be helpful. Also, for example, here we have the layout shift. We remember that cumulative layout shift is one of the metrics that are influencing the core web vitals, one of core web vitals influencing the SEO. So we can see like which element has been moved in here. and what's happening basically, which script again. So I think this is really, really useful. And then last but not least, we have Lighthouse as well, which we saw what the results look like. You just probably want to use the defaults, navigation, either mobile or desktop, and just for performance. Okay, so that was a demo time. There's way more. Okay, way more tools that can be useful. And I highly recommend the course from Harry Roberts on web performance testing and setting up for web performance testing, because it's like really a lot of things that can be done. This course takes 45 minutes. It's just so much information. If you want to, I have a discount code for 20% and iSchool. I did not come up with this, Harry did. So, you know, yeah, I know it's a bit cheesy, but it should work. So if you want to go through this course, I really think it's fantastic and gives you a lot of insight. How is standing with time? Okay, cool. So yeah, setup is the key. So we had initial testing, we had the optimizations, and the next thing is setting up for the long run. Because it doesn't matter if you optimize your performance, you're like, great, and everything is working fantastic. Next month, maybe there will be some new analytics tool added to the website, or junior developer adds a new package for icons, and like everything goes to, you know, is getting worse basically again. So you want to set up some sort of monitoring or some sort of guard. There are many tools. The ones I personally really think are beautiful. Speed curve calibrate for like having a great overview over time what's going on with the metrics. Bundle size is super easy to set up. It's you just add the how big the assets should be in your opinion. For example, okay, I don't want to my JavaScript to go over 1 megabyte or something. You can set specific files, but types of files. For example, I don't want any JPEGs to be more than 50 kilobytes, and you can set it up with the CI so that it fails the CI if someone, for example, puts too big of an image. I set it up, and it's like really saving me sometimes when I see what's like. Sometimes people are just forgetting to optimize the image or some file, and it's saving us from these mistakes. And there's also Web Vitals JS library from Chrome team. It's different than the extension. It's so you can implement it so that it sends, for example, the Web Vitals results, field data results from your users to some analytics tool. So I think it's really useful. All right, in summary, you want to remember the difference between load, runtime, perceived performance, and field and lab data. Metrics to remember: LCP, largest contentful paint; CLS, cumulative layout shift; IMP, interaction to next paint. We can already forget the FID. If you optimize IMP, then FID will be good as well. And time to first byte, my favorite metric. Tools to use: network tab for loading, performance insights, rendering tools for the interaction, runtime performance, Lighthouse page speed, web page test as well for general information what's going on. Thank you very much for listening. That was the longest talk I've ever made, and I'm like at the end of my breath. But if anyone wants to ask any questions at the end, you can hit me up on Twitter. You can chat to me here. Thank you.